Yeah. So, hi guys, let's do the LeetCode virtual contest. I just woke up a few hours ago, so I'm not able to attend the virtual contest. So, let's do it virtually. So, I'm live and let's check my audio is coming correctly. My, oh yeah, good. So, I believe, yeah, this is the contest. I'm not sure whether I'm able to solve all the four because as you can see, I'm a guardian, but I did attempted in late March this year. So it's been couple of months since I have done this. Anyways, let's start. We'll focus more on solving it rather than doing it very fast. What happened? Yeah, crazy. So you are given an integer array nums of length n. Choose an index I such that it's between this start from zero, but it doesn't include the last element. By choose an split index I, let prefix sum be the sum of first ith and suffix be the minimum of I plus one till this. Score of particular index is prefix sum minus this. Return an integer denoting the maximum score. So isn't it just straightforward? Just need max suffix and prefix sum, then brute force. Brute force means check in every index. It's just whatever the question tells. It's just that same thing. So I'll take this sum for the prefix sum, and for the suffix, let me just create one vector of int suffix max. Looks good. It should be of size n, and for now let's just take the nums of this, then equal to nums dot size. Okay, so let me just come from very behind till 0, and this suffix max of I should be equal to max of suffix max of I plus 1, and whatever we have at this position. So this particular two line will give us the maximum of the suffix. Okay. So now let's just calculate our answer. So we'll be moving from 0 till this point. Why n minus 1? Because it's already, yeah, we can also choose n minus 1. Okay. So in order to skip from this point, we can choose of having this. In that way, whatever. So what should be the value for this one? This thing and whatever the maximum from this. Oh, sorry, it's the minimum. So it should be suffix min. Makes sense. Suffix min from I plus 1 till n minus 1. So whatever, if it's n minus 1, then to split it equal to this. It's just this. Let's just see. So my sum will be just adding of this, and say would be we need the max, right? Yeah. Max of n, this comma sum minus whatever the suffix max of this I tells us, and finally we will return the sum. Let's check. I'm also not sure about this last position. Yeah, they just tell that we can't be at the last position, so it's only always this. So don't need this one. I think. Yeah. What's happening? This lumps. So see, it's already men. Let's don't make such silly mistakes, right? Just the first problem, but it says medium 1700. Okay, the answer can be negative also. So basically, I should choose 1A18 the minus terms. Yeah, because max it can goes up to is all numbers were 10 to the power 9 and length of this. So it's basically up to 10 to the power 9 into 10 to the power 5 is basically 10 to the power 14. Somehow this comes as 0. One second, I have updated this. This thing is working fine. Sum is this thing minus this, sum minus this. Mhm. Why it's coming as this? Let me just output this. Oh, I think I should take it as I plus 1 minus 2, 17 and 0. Yeah, that's the thing. Let's try giving it a try. Yeah, that's okay. So it's pretty straightforward. Okay. Let's go to the next problem. So you are given five integers: cost 1, cost 2, cost both, and need one and need two. There are three types of items available. Okay. So the item one costs this much and contributes one to the type one requirement. Cost two will cost this much and contribute one to type two. While the cost three cost this much and it will contribute one to both the types. So you must collect enough items so that the total contribution towards type 1 is at least this, and total contribution for type 2 is at least this. Minimum possible total cost to achieve this. Okay. So basically I can have this much cost to have this. I can have this much cost to have one of this, and I can have this much cost to have both of this. So basically it's like combination of two. So basically max only using, it's like only using type 1. It's basically cost 1 into need 1, and that's only using type 2 is basically equal to cost 2 into need 2. So basically the answer max bound, max would be C1, let's say this should be C2. So it's basically C1 plus C2. It's a max bound. But as you can use both also. So it must be that you can use some X amount of both. X into cost both plus we can make use of this plus cost 1 into need 1 minus x plus cost 2 into need 2 minus x. This is the particular formula which basically calculates the thing. Okay. So this particular thing can be 10 to the power 9. Okay. Mm-mm-mm. So what could be the particular value of x? It can go up to and need 1 and need 2. But that's going up to 10 to the power 9. So we can't do a brute force for this. Let's have some more observations. Here it says the when type 3 items was this. Type 1 needed is the total contribution to, okay, just used both 3 times, didn't use this much. Okay, okay. So basically, let's think at a point of view. Like the cost of 4. Cost 5 and 4 and 15th. So this particular two things were independent. Either I need to choose this, I need to choose this. Okay. If any one of the two things is more than this, then it's better to take this one. I'm saying is this is if this C1 is greater than this one and or C2 is greater than this one. So there's only three possibilities. Okay. Okay. The first one is C1 plus C2. Okay. The second one is we'll took need one times need one into cost both plus now we don't need the cost one, okay, because we already taken this much. So cost 2 into need 2 minus need 1. And the scenario 3 would be we are taking need 2 times this, then already covered for cost 2, so we'll only need this much. Yeah, I think this is like ultimate answer. Long let's say C1. What C1 is actually cost 1 into need 1. C2 is actually equal to cost 2 into need 2. Okay. Long scene 1. Okay. This one is scene 1. This one is scene 1, suppose. So it's basically this thing. So need 1 into cost both plus cost 2 into max of 0 comma need 2 minus need 1. So long scene 2, it's fairly equal. Just need 2 cost 1 minus 1 second. Yeah, I think this is the answer. So I'll fairly return minimum cost of scene 1, scene 2 and C1 plus C2. Fairly this should be the answer. Let's check. 320. What happened? Max can't be okay. It's not a long. Okay. 3, it's a 22 and it's a 0. Let's try submitting this. Mm-hmm. What's the this error? Okay. Can't be represented in int. Already using. And then this this will someday burn me out. This can't be represented in type. Same thing. Let's check if it's working. Now that this should work. Cost to another. Let's check. This thing is now working. 3 into 0 should work. Yeah, let's past. Said good, but I had done a silly mistake of doing this. Not doing this thing. Never mind, that's okay. It's already been 21 minutes. Let's focus more. So you are given a positive integer k and you need to find the smallest integer divisible by k that consists of only the digit 1. Okay, 1 second, let me just take some water. Okay, so you are given a positive integer k and find the smallest integer n divisible by k that consists of only digit 1 in its decimal representation. Return an integer denoting the number of digits in the decimal representation of n. No such integer or like this. So we are given a k. We need to find some smallest integer n which we can divide by k. But it should have only ones. One, 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 triple one, such that. Yeah. So it says isn't it just a brute force? Like find all numbers in this range. So k is from 2, right? So if it should be divisible by k, then that means k is from 2. So this number should be from 11 to dot dot dot. It should be till this much only, right? So, so these three numbers were possible only, what? It's still 10 to the power 5, right? So 1, 2, 3, 4, 5. Yeah. The number can be anything because k is still this doesn't the number doesn't need to be inside this. So What could be the observation for this? So, mm, I think what could be the upper bound of this? So, the number of ones can be how much? Let's see. So, for this number of ones is this. So, if you don't find anything, we just need to output -1. Okay. So, there should be some condition on k also, right? Not every key can divide the values of this. Uh, so it can be divisible by 3 because sum is 3, but it can't be divisible by 2 anytime because it's a what. So let's validate on k. Okay, validations on k. What are the possible validations for k? So we have the divisibles like this. Okay, 2 can't be in the answer because it's always odd. 3 can be. So as it's not 2, it can't be 4 and 6 also. It's even, not even. It can't be 5 because in order to divisible by 5, we need to have a 5 or 0 in this place. 7, can it be? Might be. And 9 can be a summation of 9. Yeah, but these values can be. So k can't be a even number or multiple of 5. So basically, if my k is value of 5, if any of this is 0, then we should return a -1. In the other case, we, we can have answer. Okay, but what is the sorry? What is the maximum bound of this particular ones? So uh, there must be 7. So if we can see here, length of n is this. 7 divides this. If we can see by 7, 158. So let me just check. Divisible by 3, not 5. Oh, sorry. Can be divisible by this. Okay. This is divisible by 3, obviously. 5. So it's only divisible by 3. So the thing I observed from here is if this number of digit can be at most, because it's a third problem, right? So number of digit can't be so much. So let's go for a 10 to the power 5, which is basically till k. So starting from only one digit, I want to go till k digit. Okay, and one second. So I'll be taking the reminder, and then every time I'll update my reminder as reminder modulo, reminder into 10 plus 1. This is 11, and this particular thing is current modulo. Okay, and if this particular reminder is 0, then we are getting the answer. Otherwise, we are getting -1. Let's check. So we are trying every possible values. Let's check. Oh yeah, it's passed. So basically, we are testing for every possible values. So it basically states that the number of the number in the final ones, this particular number, should always be at most k. We can't have more than that. How can I prove this? Not sure how can I prove this. So what I'm doing is for the remainder, I'll add one shift, then a plus, because at least the modulo can be this number, right? Or can I just write it in a simpler manner? So basically, this remainder is basically I'm making it shifting a bit to left in a decimal place, and then I'm having a plus one. That means it's basically 111 kind of a thing. And then I'm checking with key. Okay. So basically, if I can have a better answer, yeah, that's fine. I think this is fine. Next, I will just have the hardest possible question. Okay, this number of balance integer in the range. Cool. So you are given two integers, low and high, and an integer called balance if it satisfies both of the following conditions. Uh, It contains at least two digit. Integer should be at least two digit. Sum of its digits at even position is equal to sum in the odd position. Return an integer presenting the number of balanced integers in this range. So it's look like it's something related to digit debris. Mm, is it? Yeah, I think it's related to DZDP because need to find count of integers in range low to high, right? And the condition is sum of digit at even position should be equal to sum of digit at odd position. So it is particularly a digit DP question. So I need to figure it out how, and also number of digits should be at least two. Otherwise, anyways, this condition will be failed, right? It should be a digit repeat with two. So this condition will handle this at least two digits question. Okay, so basically need to count this. Let me think. It's a possible digit baby solution we can have. Is there any other possible way of doing this? I'm not sure. Let's just go with digit DP. Okay. So I will have a string s, which is basically convert this into this low into this low minus one basically for the digit DP. Okay, and then I will have a DP which is basically, oh, we can do in that way also. DP dot assign. Let's first have the DP. So what should be the value of DP? So basically it should go up to, so 15 digits are there. So it should be traveling to all the digits. So let me just put it 20. 20 digits will be fine. Then it should have odd and even. So we should also have the sum of odd and even digits. So sum of odd digits will basically 10 digits were there, and 10 into 9 is basically 90. So 100 would be the upper bound. Similarly, 100 will work for even. Then we will have this for type bound. Instead of having repeater assigned, we should have mem set dp minus 1 size of dp. And this should work. And then answer 1. This is answer 2 basically. We should first calculate the high part. High will be answer 1, and it should be digit db. Function will go with current index. Then we have if it's how many odd and even sum is there, how much. Then we should have tight bound. Yeah, I think this